Hi, I'm Paul Kyogan from GK Tuition, and in this video I want to talk to you about sequences and series. Now the question I've chosen to go through is 2015 Paper 1 Question 1. In this question we're told that Mary bounces a ball from a height of 2 meters, and every time that it hits the ground it goes back up vertically 3/4 of the previous distance. So if the first distance was 2 meters, to get my second distance I multiply the 2 meters by 3/4. That means my next distance was 3/2 meters. Multiply that by 3/4, my next one is 9/8, and to get each value I just multiply by 3/4 each time. Now notice in this case, I think the part A here is relatively straightforward. I'm just multiplying by 3/4. I think the one place you could make a mistake is, notice in bold it says fraction form. So just make sure that's the kind of thing you definitely need to highlight during your leaving cert. That's the thing that a lot of people could miss. So it said fraction form, so just make sure you leave it in the right form and that you don't give it as a decimal. Okay, so for the second part of this question, we're asked to find in meters the vertical distance the ball had travelled when it hit the ground for the 5th time. So that's what basically this distance. So it's bounced once, twice, 3 times, 4 times, 5 times. So vertically, how high up and down has the ball travelled? So clearly the first time it just went down 2 meters. Okay, so the first one it just went down 2 meters. For the next one it went up 3/2 meters and then down 3/2 meters. So it'll be 2 multiplied by 3/2. So it went up that much and then down that much. For the next one it went up 9/8 and then down 9/8. So I also want to multiply this one by 2. So let's keep it the 2 outside the bracket and this 9/8. For the next one I went up this distance, down this distance, so I also want to multiply that by 2. So it's just 27/32. And obviously the last one as well went up that distance, down that distance, so I'm also multiplying it by 2. So it's just 81/128. And now what I want to do is plug all of that into my calculator. My final answer works out as 653/64. And again, just the one thing to watch out for here, it said to find it in meters, so just make sure that you put in your units in this case, that you mark in that it's meters. It said to leave it in fraction form, so you make sure you leave it as a fraction as opposed to a decimal. Okay, so for the third part of this question, we're asked that if the ball was to continue to bounce indefinitely, find the total vertical distance that the ball will have travelled. So what you need to recognize here is that after the first bounce, the ball is doing the same thing. It goes up a certain distance, down the same distance the whole way along. But what we need to do is separate the first one, because the first bounce, it just goes down 2 meters, but it never goes up to 2 meters. So we can say all the rest of these bounces form a pattern, but the first original 2 meters is not included in that pattern. So if we just go from, say from this point, if I wanted to find the vertical distance, if this was to continue indefinitely, you should recognize that this is a geometric series. Okay, so I want to find the sum to infinity. If this happens forever, I want to know what is the total vertical distance. So I want to find, if this was to happen indefinitely, my sum to infinity, which is a over 1 minus or. Okay, and in this case, a will be the first term. So what was the total vertical distance travelled from the ball hit the ground here until the ball hit the ground here? Well, it went up 3/2 meters and it went down 3/2 meters. So that means my first term in this sequence is 3/2 plus 3/2, which is 3 meters. So the total distance travelled from here to here in vertical direction was 3 meters. And then part or, then I need to also find my or. Or is my common ratio. So to get your common ratio of a geometric sequence, it's one term divided by the previous term. So what I would do in this case is I could get the vertical distance travelled going from this point to this point, which is 9/8 plus 9/8, which is 18/8. So my second term in this sequence is 18/8. Take my second term, divide it by my first term, which is 3 meters, and you'd work out that your common ratio was 3/4. And of course that was given to us in the question anyway, that we knew we were multiplying by 3/4 every time. So if I sub into my sum to infinity, I'll find the total vertical distance travelled from this point to infinity, if this was to continue indefinitely. So in this case, my sum to infinity will just be 3/1 minus 3/4. 1 minus 3/4 is 1/4, So 3 divided by 1/4 gives me 12. So the vertical distance traveled from here to infinity is 12 meters. Now we have to consider this. So what was the vertical distance traveled up to this point? Well, originally we threw the ball from 2 meters. So that just means it must be the 12 meters plus 2 meters, which means the total vertical distance traveled from the ball was dropped originally adds up to 14 meters. And again, just vitally important to make sure you don't forget your units. Okay, so again, I hope this video made sense. If there's anything you're unclear on, then just let me know in class or send me an email and I'll try to go through it. I'll try to explain it differently.